Well, this is the lowest grade problem, and this is version A of the midterm. I think this problem received approximately 55%. There are not many lowest graded problems this time, so I usually discuss the problems which are graded below 70%. This time there are only two of them. Alright, so here in this problem we need to find the terminal voltage of the battery 2. So there will be a current in this loop. It is natural to define this in the following way, just from positive terminals of these batteries, right, to the negative ones. Okay, so the current I will call here I. Alright, next there are multiple ways to solve this problem, but since we have such a powerful tool as Kirchhoff's rules, then it's more natural to solve this problem using Kirchhoff's rules. And for this, I'm going just to follow the procedure of the application of the Kirchhoff's rules, although it's somewhat simplified over here only because we do not have any branches. So there will be no node rules, there will be only loop rule. And for the loop rule, I need to specify the potential difference across each device in this circuit. So I will start with the batteries. For the batteries, the potential difference is from short to long terminal, from negative to the positive terminal, as indicated in this figure. And for each resistor, the potential difference is against the current. All right, so these are the potential differences. And we see that for the battery 2, if I would think about the terminal voltage, then it's going to be lower than epsilon 2, right? So why it's going to be lower? Because we have to compute the potential difference across this device over here, and epsilon 2 will come to the final answer with the opposite sign to the potential difference given by this internal resistor. But we will see this in the equation just in a second. So let me remove the purple line for here for now. From here for now. So right now let's consider the current, the voltage loop rule. I will start from the second battery, and I will go around that loop in this order. So I will just proceed writing down all the potential difference as I follow this loop. So the first device which I encounter here is the battery over here, and it gives me positive potential difference. Next is the resistor R1, and it will give me negative. Next, again, the battery gives me positive. Here, it's gonna give me negative again against the current, and so on and so on and so on. So let me just write the equation. So for this loop, it's only one loop, so I'm not gonna name it. I'll just write loop rule. Will give me epsilon 2 minus the current, which I don't know yet, R1 plus epsilon 1 minus the current, which I don't know yet, times the resistance R. Next, minus I times resistance 2. And finally, I return to the beginning where I started, so equals 0. So now this equation I can simplify because the current enters into three equations, and it is can be rewritten in the following way. So epsilon 2 plus epsilon 1. Now I will pull out the common factor is negative I, R1 plus R2 and plus capital R equals 0. And here you can actually realize or recognize that the same result you would get if you would be simplifying the circuit. So this is nothing else but the internal the equivalent resistance, and this is just the EMFs of these batteries connected in series. All right, so let's simplify this equation and solve it for the current. The current from this equation will be epsilon 2 plus epsilon 1 divided by R1 plus R2 and plus capital R. We can substitute the numbers at this point. So epsilon 2 is 1.1 volts, plus epsilon 1 is 1.4 volts, and is divided by R1 is 0.11, R2 is 0.15, and R is 3.1. So it's going to be 6, 3, 3. 336 in the sum. Let me check again. 6, 2, 3. Yes. All right. And again, so ohms. And simplifying this, we will get 2.5 volts divided by 3.36 ohms. At this point, we will use our calculators and compute this ratio. I obtain 0.74, and the units are going to be amperes. All right, very good. So now what we want to find is the potential, is the terminal voltage, and the terminal voltage will be defined as a potential difference between these, across this device. Let's call it delta V terminal. And delta V terminal, I mean, from the picture you can see that delta V terminal is going to be consisting of the two contributions. It's epsilon 2. It's epsilon 2 is a positive sign because the direction of the potential difference of the terminal voltages I defined is the same as the potential difference of the EMF. All right, minus. Now the potential difference due to the internal resistor in the opposite direction. So minus the current, which we just found, times R2. All right, so now I'm going to substitute the numbers. It's 1.1 minus the current, 0.744 times 0.15 times 0.15, and the answer is going to be in volts. So at this point we are going to use our calculators. And I obtained 0.9884, we don't need this precision, volts. All right, and this is the answer, E. In principle, this result can be recognized quite simply. So let's look at the possible results over here. So the possible results here are 231, 100, 1.1, right, 1.21. So this I can immediately discard, again, just because I can see this connection of the batteries. I see that the current is going to be in this direction. And if it's in this direction, the terminal potential difference, the terminal voltage, is going to be less than the EMF. Okay, so it has to be less than 1.1. Okay, so there are only two numbers which are less than 1.1. It's E and C. So, and now, of course, to actually be able to tell if it's E or C, one has to solve it. But looking at these problems, again, so this the EMFs are approximately of the same order. The internal resistance is approximately of the same order. And therefore, I would expect to see just a tiny shift in the EMF. And this shift has to be towards the smaller values if I want to compute the terminal voltage. Okay, and that's the only answer which would satisfy this E. I mean, of course, all this discussion is only will only help you if you actually know how to solve this problem. It is more answering the question if your result is reasonable. And indeed, it's reasonable. It has to be less, okay, than the 1.1. And it shouldn't be less by much, so it cannot be C, right? So that we end up with E, but straightforward calculation showed the same.